This is the third part of lesson 1.1. What I'm actually going to do here is some more examples, some that are a little more advanced and detailed, mostly because they have more than one step in them. But just to review, what we're doing is we're translating word phrases and sentences into expressions and equations. And that way we can do real life and word problems represented using algebra. You need to make sure that in your notes you have got the 3 steps written down, which is to choose a variable for the unknowns, choose an appropriate operation, and then write the representative equation or expression in an order that reflects the nature of the problem. Also in your notes, you do need to have all these key words written down. They're what helps us recognize what the operation is. Right here's some more of them. Make sure you have them written down. So you pause the video if you're needing to get those down. These right here and these right here are the words that cue into us that it is a sentence, an algebraic sentence instead of just an algebraic expression. And that's because of the word is. It lets us know it's either equal or that's less than, greater than, one of those 3. Okay, let me see, what else do we need to discuss? Another thing is the exceptions to the rule. Now I only have 2 of them written down here. For some reason it doesn't always carry over the other 2, but I can tell you what they are. And these should be written down also. The exceptions to the rule are more than, less than, added to, and subtracted from. If you have those words, that wording, you don't write it in the exact same order as what it's written. The amount that it's more than or less than is being added to or subtracted to should come at the end of that expression, not the beginning. And one other thing that we discuss is that when you see the word or the words, the quantity, you need to use some parentheses because it's saying to do it to that entire expression. Okay? And we'll run into an example of that, I believe, in the examples today. So, without any further ado, let's go ahead and get on to the examples. Okay, here are the examples I want to do in this video. And hopefully I've given myself enough space. I'll make a note to myself in the future to leave myself a little more room when I type these up. But anyway, let's see what we can do. On the first example, it says 1/2 times the product of the base and the height of a triangle. Well, the things that I don't know right here are the base, which I'm going to call B, and the height, which I'll call H. And now I need to look for my operations because that's the only things I don't really know. 1/2 times, and it's going to be 1/2 times what? The product. Okay, now the product is letting me know that we're going to have to multiply the 2 things that I'm getting the product of, which is the base and the height. So when I write this out, it should look like something like this. 1/2 times the base times the height. Okay. Another way they could have said this is 1/2 times the quantity of the base times the height, and in that case we would have put some parentheses, but that gives you an idea. Okay, so the answer right there is 1/2 base times height. The next one says the area of a trapezoid. That's something we don't know, so I'll call that A. Equals 1/2 of the quantity. Okay, we're going to have some parentheses here. of the base, call it B, oh, base 1. Okay, so we're going to have a subscript, plus base 2, put a little subscript there, multiplied by the height of the trapezoid. So the height we don't know. We'll call that H. Now, a little note on these subscripts, because you may not be real familiar with them. If you have more than one of something, like we have, a trapezoid is going to have two bases. A trapezoid looks like this right here, and the two parallel sides are known as the two bases. Okay. You can put a subscript on a number, and on a variable, and it doesn't mean that you're going to add, subtract, multiply, or divide by that number. It's just a label. It's a label saying the first base and the second base. It started to sound like baseball, isn't it? All right. Let's go ahead and see if we can write this. I do need to find my operations. I see the word equals, so it's going to be a sentence instead of an expression. It's going to be an equation, actually. Half of the quantity of means we're going to do times. Quantity lets me know I'm going to have parentheses. It's base 1 plus base 2, and then we're going to multiply by the height. Okay. I'll write this out. It looks like this. Just writing it left to right the way we're reading it. The area of the trapezoid, A, equals 1/2 of, that's going to be times. I'm going to go ahead and use parentheses because it says of the quantity. So, all right, the quantity of what? Base 1 plus base 2. And then we're going to take that quantity and we're going to multiply by the height. There. And that's the equation that will give the area of a trapezoid. And if you want to put a little subscript on there so you know that that's the area of a trapezoid, not a triangle or something else, that's fine. All right, example 3. A number is 8 less. Hold on, I'm going to zoom in just a little bit here. Let's see if I can get a little more space. All right. A number is 8 less than the product of a number and 2. So, we got a number. We'll call that n. Is 8 less than the product of a number. There's another. Now this apparently is a different number. Maybe I should have worded this problem a little different and said of another number, but let's call this number x and 2. All right, let's find our operations. The operations I see is, which is going to mean equals. It says 8 less than. Now, less than wasn't our exceptions. So it doesn't mean I'm going to put 8 minus. I'm going to put minus 8 on the end, all right? 8 less than what? All right, we have the product, which is going to be multiplication of a number and 2. Okay, let's see if we can write this. Left to right, it says a number n is equals 8 less than. So I'm going to put the minus 8 back over here. 8 less than what? The product of a number and 2. Now that's n times 2. But remember we said that when you have a variable and you're timesing by a number, it's conventional to put the number first and the variable after. That way it doesn't look like x squared. Okay, so there we go. That wasn't as bad as what it sounded like. Next example, Mike's age. I don't know Mike's age, so I'm going to underline it. We'll call that M. is at least, there's an operation, 6 years more than, there's another operation. Now here's one we haven't discussed yet, but I think we can probably figure it out. Twice Fred's age. If we're going to do twice something, we could add it to itself, but the best way to do it is just to say multiply it by 2. Okay. And then another unknown we have here is Fred's age. Now you'll notice I didn't use A for age, and the reason why is we've got 2 different guys' age. We'll call Fred's age F. So if I write an equation for this, it says Mike's age, which is M, is at least. Now, is at least means the smallest it could be is this other thing. So that means that Mike's age has to be more, or at least equal to, 6 more. Okay, more than is one of those exceptions to the rule. We're going to have to add 6 on the end. We're not going to do 6 plus. And then twice Fred's age. Twice Fred's age would be 2F. Okay, and now we're down to the last example. It says when a number, I don't know what the number is, so we will call that, I'll call it N, is divided by 3. Well, there's our operation, so we'll go ahead and underline that. And the quotient, now I think when we say the quotient here, we're talking about this number divided by 3. So the quotient we just, well, that makes me think that this isn't an equal. We'll figure that out as we go. When a number is divided by 3 and the quotient is increased by 18, the final result is, there's the equals, 99. Okay. The wording on this one's a little bit funny, but I think we can figure it out if we just kind of get started writing. It says the number is divided by 3, and the quotient, that's what we have right there, is increased by 18. So let's take that this division right here, and we're going to add 18. I probably shouldn't have drawn a box around that. Makes it look like that's the answer, huh? It's increased by 18, and the final result is, so equals 99. That was far easier than what it sounded like. So that's it for examples. Make sure that you do the practice worksheet, and good luck. I think you shouldn't have very many problems on this. Make sure to follow the steps.